Alright, in 13.5 we're going to look at what's called the pooled t-test. And we're going to start this one with an example. So imagine if you bought a used camera in good condition from a friend versus if you bought the same item from a stranger. So imagine an experiment where we ask someone to imagine doing this, and let's just think before we look at the results what might happen. So what's influencing your mind from a friend is, well, if I offer them a really low price and then they feel like I cheated them later, like I got it for too good of a price, that might hurt the friendship. So we might be willing to offer a much lower price to a stranger because we might think, well, I'll never see him again, so if I can get this camera for a great steal from this stranger, then it's not a big deal. On the other hand, you might imagine someone might say, "Ooh, they're my friend. I bet they'll give me a really good deal on it just because, our friendships, you don't want to charge them as much." So they might actually offer their friend lower. So you can kind of imagine both cases. So here's the results. Buying from a friend is this column, and buying from a stranger is this column. And we'd have to actually run some statistics on this, but it looks like buying from a stranger, we do have several numbers that are lower. In fact, so it's the same person and they're responding twice. So this person said friend higher, so did this person, the next person, the next person. I think every single person was willing in this study to offer more to the friend. And there's no data on this last one, which could happen. Maybe they just couldn't decide on a number, so we don't have one there. Okay, so to do the pooled t-test, our usual null hypothesis is the same as it was in the two-sample t-test. We're going to assume that these two different groups are no different. So we will assume that the mean price offered from group 1 is the same as the mean price offered from group 2. So if we subtract them, it's 0. And we're going to see a new degrees of freedom formula for this one as well. So the first thing we're going to do is we're going to calculate the variance for this pooled group. And so what we get is another equation, and so the pooled variance is only dependent on the variance of group 1, the variance of group 2, and then the size of group 2 and 2, and the size of group 1 and 1. And it becomes a plug and chug if you know those things. And the standard error of the pooled group is going to change a little bit. So before, this equation was s1 squared and this was s2 squared, but the s pooled is going to take the place of s1 and s2 because we're pooling the variances. So we have s squared, we have s pooled squared in both, so we can factor it out and pull it out of the square root as something to the 1 power instead of to the 2nd power. You don't have to worry too much about how this math is done. Just know that this is the equation. So we have the standard error for a pooled t-test is just the s pooled times the square root of 1 over the sample size of group 1 plus 1 over the sample size of group 2. And our degrees of freedom formula is going to simplify quite a bit. So instead of that big long equation we looked at previously, we're just going to take the sample size of each group, subtract 1, and then add those two numbers together. So the key to this one is our assumption is that the variances are equal. So the variance in numbers from group 1 is the same as the variance of numbers in group 2. Now let me bring this back to the camera example. So group 1 was, think about how much you would offer your friend for the camera. Now you're going to come up with a number, let's say $200. Your variance is going to be plus or minus. So you might say, I've got $10 wiggle room. So we can think of that as like the variance. Well, that's not quite the variance, it's the standard deviation, but let's just think of it that way. So I have a certain wiggle room, plus or minus, on my price of $200. Now, this says in group 2, when I'm selling to a stranger, I'm probably going to use the same wiggle room. So if I offer the person less, like let's say 150, my wiggle room might still be plus or minus $10, like it was if I bought from a friend. So this kind of assumes that the the variance, the differences in my number that I'm willing to pick or land on is going to be the same between these two groups. Now this is actually a pretty rare situation to have variances that are the same. In fact, it's difficult to even come up with examples. That's why this camera example is pretty good, because it's you just answering a question twice. So nothing's going to change in your decision process other than the fact that we're comparing a friend versus a stranger. But things like variance probably aren't going to change in that case. Okay, if we want to do a confidence interval for the pooled t-test, it's very similar. We're gonna have our typical assumption that the means are the same, so when we subtract them, we get 0. And then our t-statistic for this one is going to be very similar. We're going to have our mean subtracted minus this delta naught. Again, this is typically 0, so it typically goes away, divided by now our standard error of pooled, which was that equation we saw on the previous slide. And here it is again. So the standard error, we just calculate using this, and we use S pooled inside of here, and so we can crunch those numbers out and then use those to find a confidence interval. So we would have difference in our means, a t star based on degrees of freedom, that degree of freedom equation. We would then look this up based on our confidence level, so we'd have to use the t chart, the t table, and look up degrees of freedom here via this equation and our confidence level, and then we would multiply that by our standard error pooled. So it's very, very similar to how we've been doing confidence intervals. We just have our equations changing slightly. Okay, so you can do the pooled t-test. It's in the various packages you might have. So in like something like StatCrunch, you have to click the pooled option. In your Texas Instrument calculator, there's an option when you do a t-test to highlight pooled. You'll want to just highlight pooled. So we will try to, whenever possible, use our software, use our hardware to actually calculate this instead of doing a lot of these equations by hand. That will do it for 13.5. Actually, let me go back to one more thing on this slide. So, when should we pool? Well, you should pool when you know those variances are equal. But again, like I said, that's pretty rare. So it's actually more correct to not pool, and that's to use the two sample t-test, which is what we've already looked at, which we've already worked on. So obviously in my math lab, though, they're going to want you to use pooled, so they're going to say if we pool then, so you're going to need to use these equations and things. But if you're doing statistics in the real world for real problems, it's probably not the case that the variances are equal, so you would probably not use a pooled t-test. So that's just one thing I wanted to add there, and that should do it.